Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. This second video lecture of week second for the course Biostatistics 1 is the continuation of my previous first video lecture. In the first video lecture, we have learned about the frequency distribution. Now, in this second video lecture, we are going to learn about the relative and cumulative frequency distribution.
Now, relative frequency and percentage distribution. How to calculate the relative frequency of a category? A relative frequency of a category can be calculated by the formula frequency of that category divided by sum of all category. This formula is very important for the relative frequency of a category. Now, calculating percentage, relative percentage distributions. Percentage is equal to relative frequency multiplied by 100. Suppose we have a solution. In the previous slide you see over here, these are the classes 124 to 145, 146 to 167, and so on. Now how to calculate the relative frequency and percentage relative frequency. These are the relative frequency. The relative frequency formula you see over here, frequency of the category, you see over here, the frequency of the category is 6, and now divide by sum of all frequencies. 6 divided by 30, which is equal to 0.200, and 0.200 multiplied by 100, we obtain the percentage frequency. So to find the relative frequency, for the relative frequency, divide the frequency of the category by sum of all frequencies. This is the frequency, this is the frequency of this category. The first category frequency is 6, and sum of the all frequency is 30. So 6 divided by 30 mean 1 by 6, 1 the 6, and 6 5 the 30, 1 over 5, and 1 over 5 mean 0.200, and the percentage relative frequency is equal to relative frequency multiplied by 100. Now similarly, the relative frequency for the second category, the frequency of this category is 13, and sum of the frequency is 30. So 13 by 30, we obtain a relative frequency which is 0.433, and the percentage relative frequency is 43.33. So you see over here, these are the relative frequency of other categories, and these are the percentage frequencies. Now sum of the all relative frequency, you see over here 0.999, and sum of the percentage frequency 99.9%. Now another example, after conducting a survey of 30 of your classmates, you are left with the following set of data on how many days of each employee has taken this year. You see over here, this is actually the raw data, and this raw data, the smallest value, the minimum value is 2, and the largest value is 36. Now to construct a group frequency distribution table for this raw data. So first of all, this is the classes from 2 to 8. You see over here in this table, the smallest value is 2 and the largest value is 36. So from 2 to 8, these are the number of classes 1 2 3 4 5. So in this table we use the thumb rule. Number of classes not less than 5 and not greater than 20. And we can also take the number of classes not less than 8 and not greater than 15, suppose. And but you can easily use the thumb rule. This is very interesting to use the thumb rule. So class limit from 2 to 8, and from 9 to 15, 16 to 22, 23 to 29, and 30 to 36. So in each class there are 6 class interval, and the frequency for the first class is 14. Why the first class frequency is 14? From 2 to 8 there are 14 numbers. You can count these results for 2 to mean or 2, 6, 9, and 10, and similarly 11 and 5, you see over here 5, and again 9, and the other number is 10 and 4, again 9, 9 and 8 and 7, and again 8, you see over here 7 and 9. In the first class actually we have 2 to 8. So 2 to 8, from 2 to 8 we have 14 numbers. 2 to 8, 2 to 8, 1, 2, 3 and 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and 14. So in this class we have 14 numbers. So the frequency for this class is 14. Now to tally: 1 2 3 4 5, and 1 2 3 4 5 5 5 10, and 10 plus 4 15. So this is the tally. Now these are the classes, and these are the tallies, and these are the frequency. So first of all, decide the number of classes, then decide interval for each class, and then construct the classes column, and second column will be obtained the frequencies, and then tally for the calculating data. Now, another example, there are some characteristics: somewhat, non, somewhat, very, very, non, very, somewhat, somewhat, very. So you see over here, and so on. In this table, we obtain some characteristics. Now, to construct the ungrouped frequency distribution table for this data, the ungrouped frequency distribution table you see over here, without group, this is actually called frequency distribution. So the frequency distribution vary, vary, stress on job, vary statement used 10 times. You see over here in the these slides, vary used 10 times. So in the first column, 1 2 3 4 5 6 7 8 9 10 11 9 10. So use 10 times, vary verb, vary statement used 10 times, and the frequency for tally for this 1 2 3 4 5 1 2 3 4 5 10. So this is actually called frequency distribution without group. Now determine the relative frequency in percentage frequency for the data, and we know that the relative frequency can be determined by the frequency of the category divided by the sum of the category. So frequency of this category is 10 and total sum is 30. So 30 by 10, 0.333, and 14 by 30, 0.467, 6 by 30, 0.22, and this is the percentage. Relative frequency multiplied by 100, we obtain the percentage frequencies, percentage relative frequencies, and you see over here. Now, another example. The following data give the average travel times from home to work in minutes for 50 states. The data are based on the sample survey of 70,000 households conducted by the Census Bureau USA today, August 6, 2001. Now these are the raw data. To construct the frequency distribution table and construct the frequency, relative frequency and percentage frequencies, and we have already discussed the results by some examples in the previous slides. So for the classes, first of all, approximate the width of each class is 31.2 minus 15.4 divided by 6. Suppose we want to construct the data in 6 classes. In the first class is suppose 31.2 to 15.4. 31.2 actually is the largest value. F15.4 is the smallest value. So smallest value minus largest value divided by the number of classes. First of all, decide in mind that the number of classes should be what. If we want to construct the data in 6 classes, then highlight the largest value and the smallest value in the table, then subtract the smallest value from the largest value, divide by the number of classes. You can easily get the width of the classes, interval of the classes, which is 2.6, and roundabout we can write that the class interval is suppose 3, but we can also calculate each class in this interval, by this interval 2.6, because the given raw data is in decimal form. So the first class is 15 to 18. 15 to 18, there are three gap class intervals. So round about this 2.6 up to 3. So the class interval, the width of each class is 3. Now 15 to 18, 18 to 21, 21 to 14, 24, 24 to 27, 27 to 30, and 30 to 33. Dear students, main point, the most important point, note that actually in this example, our class boundary of the first class is ended at 18 and the boundary of the second class is started again from 18. So this is actually class continuous class boundary. But in the previous example, you see over here, this is the examples 2 to 8, now 9 to 15. The last boundary of the first class is 8 and the first boundary of the second class is 9. So this is actually called the discontinuous group distributions. Discontinuous, 8 to 9, discontinuous. But when the class end is 8 and the second class again start from 8, then this data will be called continuous data. Now, in this example, you see over here, this is actually the continuous data. Now, the frequency of the first class is 7, second class is 7, third class 23, fourth class 19, fifth class is 3, and the last sixth class, the frequency is 7. Actually, in the last class, the frequency is 1 because 30 to 33, maybe there is one number, 30 to 33, 30 to 33. There is no number in the 30 line, so in the third row, one number, no number will be 30 to 33. This is the one number only in this range. No, there is no another number in the range 30 to 33. So the frequency is 1. Now the relative frequency. The frequency of this category is 7 and the total frequency is 50. 50 mean total numbers of items in this actually 50. Now 7 by 50 we obtain the relative frequency 0.14 and the percentage 0.14 multiplied 100, this is 40, and so on. We can find the relative frequency for each category and percentage relative frequency for each category. So dear students, the sum of the relative frequency will be 1 or approximately equal to 1 and the percentage frequency sum will be 100%. Then the result will be true. Now another example, the administration in a large city wanted to know the distribution of a vehicle owned by household in that city. A sample of 40 randomly selected households from this city produced the following data on the number of vehicles owned. Construct a frequency table for these data and draw a bar graph. So this is a very simple example. Actually, in this example, I want to tell you how to present the data by table and how to represent the data by the graph. So this is actually the raw data. First of all, construct the frequency distribution, and then if you want to construct the frequency the group frequency distribution, then we can also write the group distribution. But for the only frequency distribution, 0 repeated one time and two times. So 0 repeated two times. So the frequency of 0 is 2. Similarly, 1 repeated 18 times, 2 represent 11 times, 3 represent 4 times, 4 3 times, and 5 2 times. So the number of all household is 40. So the relative frequency distribution 2 divided by 40, and similarly for for this category 18 divided by 40. But in this example we want to construct the frequency distribution table and then present the data by the bar graph. So this is the bar graph. These are the number of household which has no graph. These are the number of household which have 1 car, 2 car, 3 car, 4 cars, and 5 cars vehicle owned. These are the numbers of household which vehicles own. Now these are the frequencies. Actually in these frequency, the largest frequency is 18, and the smallest frequency is 2, you see over here. So for the bar chart, we start suppose from 0, and from 0 to the largest frequency, which is 20. Now since the no car vehicle owned, 0 mean no vehicle owned, frequency is 2. So frequency is 2. So this bar graph is front of 2. Now vehicle, one car owned, one car volt frequency is 18. So you see over here, this is in the front of 18. Now another bar for two cars vehicle owned, and for two cars vehicle owned, the frequency is 11. So the frequency is 11. So you see over here, this is 10, and now suppose this is 10, and the moment we have 10, 11. So this is in the front of 11. Now three cars won. Three car one frequency is 4. Now you see over here, this is 4. This is in the front of 4. And now four cars won. Four car owns frequency. Four car owns frequency 3. And you see over here, this is in the front of 3. Front of 3. And five cars frequency is 2. You see over here, 2 repeated 2 times, frequency repeated 2 times, 2 and 2. For no vehicle on car, frequency 2, and for 5, frequency is 2. So this is the bar graphs for tables. Now cumulative frequency distribution definition. A cumulative frequency distribution gives the total number of values that fall below the upper boundaries of each class. For example, using the frequency distribution of table in previous example, reproduce in the next slide, prepare a cumulative frequency distribution uh, for home runs hit by Major League Baseball teams during 2002 season. You see over here, this is actually the frequency distribution, the group frequency distribution of the previous example. You see over here, this is the frequency distribution table. This is the frequency distribution table for the league team. You see over here, these are the league teams, and for the league teams we have frequency distribution table. You see over here. Now for this table we want to calculate the cumulative frequency. So to calculate the cumulative frequency, you see over here, the cumulative frequency. These are the class limit 124 to 145, and this is the frequency. And 124 to 167. First of all, start the classes from lowest limit to largest limit, and then write its frequencies. Now for the cumulative frequency, this frequency 6 is it is. Now add 13 with this, the cumulative frequency will be 19. Now add 19 to 4, the cumulative frequency will be 23. Now add 23 to 4, the cumulative frequency will be 27. And now add the 27 to this 3, the cumulative frequency will be 30. So dear students, the last results of the cumulative frequency will give you the total. And this example, the total is 30. You see over here in the previous example, the total is 30. You see over here, the total is 30. The sum of the frequency is 30. So in the cumulative frequency, the last cumulative frequency gave the last result of the total. The last cumulative frequency gave the total sum of frequencies. So this is actually the cumulative frequencies. The cumulative frequency represent that from position number 1 to 6, this class appear. Actually, this represent the positions. From position number 1 to 6 represent this class, and from position number 7 to 13, from position number 7 to 13, this class is represented. So this is actually called the cumulative frequency, and we can easily find first frequency right as it is, and then add the consecutive 6 to 13, 19, 19 to 4, 23, 23 to 4, 27, and 27 to 3 we obtain 30. And we can write individually 6, no, 6 plus 13. And for the third cumulative frequency, 6 plus 13 plus 4. And for the second class frequency, 6 plus 13 plus 4 plus 4. And for the last cumulative frequency, 6 plus 13 plus 4 plus 3 is equal to 30. So this is the procedure for the cumulative frequency. Now cumulative frequency distributions continued here. To calculating cumulative relative frequency in cumulative percentage, cumulative relative frequency can be calculated by the formula cumulative frequency of the class divided by total observations in the data set. And cumulative percentage, cumulative relative frequency multiplied by 100, we obtain the cumulative percentage. Now, cumulative relative frequency in cumulative percentage distributions for the home runs hit by baseball team in the previous example. Actually, 6 is the frequency of the first category, and 3 is the total sum of the frequency. So, cumulative relative frequency is 6 by 30. Cumulative relative frequency mean cumulative frequency of each category divided by the sum of the all frequencies. You see over here cumulative frequency of the class. Cumulative frequency of the first category is 6. Now 6 divided by 30. And the cumulative relative frequency 19 divided by 30. Dear students, note that one is the relative frequency. A relative frequency can be found by frequency of the category divided by sum of the all frequencies. And cumulative relative frequency can be calculated by cumulative frequency of each class divided by sum of all frequencies. So the cumulative frequency of each, the first class is 6, for the second class is 19, for the third class is 23, for the fourth class is 27, and for the fifth class the cumulative frequency is 30. So divide each individual cumulative frequency by the sum of the total frequencies. You can obtain the cumulative relative frequency for each category. And now multiply these results by 100, we can obtain the cumulative percentage frequency. Now shapes. A graph shows the shape of the distribution. A distribution is symmetrical if the left side of the graph is roughly a mirror image of the right side. One example of a symmetrical distribution is the bell-shaped normal distribution. On the other hand, distributions are skewed when scores pile up on one side of the distribution, leaving a tail of a few extreme values on the other sides. Positive and negative skewed distribution. In a positive skewed distribution, the scores tends to the pile up on the left side of the distribution with the tail tapering off the right. In a negative skewed distribution, the score tends to pile up on the right side and the tail points to the left. And you see over here symmetric distribution. Symmetric distribution, the shape of the bell is normal to the right and the left, and this is also the left skewed and normal skewed are equal, so this is called symmetric distribution. And skewed distribution, the bell skewed on the one side, positive skewed, bell skewed to this side and bell skewed to this side. So for the positive skewed, the bell skewed on the right side, and for the negative, the bell skewed on the left side. And you see over here, this is the symmetric distributions, and these are the two distribution type, positive skewed and negative skewed. So dear students, in this video lecture, the conclusion of this video lecture is how to convert the raw data in frequency distribution, how to convert the raw data in group frequency distribution. There are two types of group frequency distribution. One is discontinuous and other is continuous. And then how to construct the daily for the frequency distributions, and how to find the relative frequency, and how to find the percentage relative frequency, how to find the cumulative relative frequency, and how to find the percentage cumulative relative frequency. And you obtain all the answers for these questions in this video lecture.